This question is taken from the NSAA 2020 Section 1 paper, and it is question 37 of the Physics subsection. A parachutist of mass 80 kilograms drops from a plane travelling at 40 meters per second 2,000 meters above the Earth's surface. The parachutist hits the ground at a speed of 5 meters per second. How much work is done by the parachutist against drag forces during the fall? So how could we work out the energy used or the work done against the drag forces during this? Well, we know that drag forces tend to vary with speed, so it might not be wise to use their force times distance, because the force will keep changing, so we can't just use a constant force times distance. So that would not be a wise option. But what could we use? Well, the information we do know is the height they start at, the speed that the parachutist begins with, and then the speed that they end with. So because this is an energy question, it might be useful to know the energies before and the energies after, and then any discrepancy will be due to the drag forces. So the initial energy is half times 80 times 40 squared, so this can be the initial kinetic energy, plus 80 times 10 times 2000, so the gravitational potential energy. And then the final energy is half times 80 times 5 squared. So the initial energy will be quite large compared to the final energy, so it seems like there will be a lot of work that needs to be done just from eyeballing these. So we notice that they started with a speed of 40 because the plane was travelling horizontally with a speed of 40. So that was the initial kinetic energy it had. So if it was just dropping straight down initially from rest, then we would have had no kinetic energy, but we did have this large amount of kinetic energy to begin with. So the work done against drag forces must just be the initial minus the final, because if this was 0, then there must have been no work done against drag forces, so there'd be no energy lost. But if this is not 0, then we know that the difference will be due to the drag force work. So if we put the numbers in, we have 40 times 40 squared, so half of 80 is the 40, plus 1.6 million coming from this, and then minus the 40 times 5 squared. So if we do the calculation, this is 64,000, because it's 40 cubed, plus 1.6 million minus 1,000. So this is simply 1.6 million add 63,000. So the answer is 1,663,000 joules. So this is the answer. And this is the work done by drag forces, or the work you've done against drag forces during the fall. So you've lost quite a lot of energy. So your final energy was only about 1,000 joules. So quite a lot of energy has been lost during this fall, and that's to be expected as they used a parachute.